I want to welcome all of you. Thank you very much for joining us today for our event, the Digital Twin for Education and Training. I want to just very briefly introduce why we have this weird acronym as our name. So I'm Matthias Grosch from the cluster Nano Micro Materials Photonics from North Rhine-Westphalia. We are dealing with these name-giving technologies, nano, micro, new materials, photonics, and lately also quantum technologies. And the thing is, today we're talking about digital twins, and digital twins is a cross-sectional technology that's involved in all of these or related to all of these technologies. I think easiest for, we could say, is microsystems. You need all the MEMS devices as sensing for your digital twin to accumulate your data. Just as one example. Just a few words about NMWP. So we're a cluster. We have a joint industry association with mixed industry and scientific contributors, so that we have an ongoing exchange and know what's the North Rhine-Westphalian actors doing and how's the other side doing and looking. And then we have in the background, that's you will also see the logo sometimes, the NMWP Management GmbH, because a cluster cannot join European projects, but the Management GmbH can do. So that's who we are, what we're doing. What we're doing a lot of networking, events like today. Soon, hopefully, a lot of more face-to-face events. That's what we're really looking forward to. But this one, for example, we didn't know when we started planning, so we thought, okay, let's go online. I mean, technology is digital twins, so why not do a digital workshop? It's not the worst. Yes, we do a lot of face-to-face events soon to come again. You can find us at business fairs. We have working groups, something like similar to this, where we exchange on a specific technology, matchmaking events where we connect science and industry from the same technological area. And we have a lot of online and digital events. Now my presentation is not going. For example, this video you will also find named under the NMWP Innovation to Go series. We also had a webinar series about digital twins. If you missed that one, maybe check out a few of them. Yes. You probably are all already registered. We do our events there. We do a lot of news there. You can get connected to North Rhine-Westphalian, but also broader stakeholders, Germany, Netherlands, Belgium, all around at our portal. And with this quick introduction, I want to dive into the topic of digital twins. What is it? I guess we have a pretty skilled participant round, but nevertheless, let me just quickly talk about what is a digital twin. We have heard the word. Okay, it's a twin. It's digital. So we have where's my pointer? We have a physical object and we have a digital or virtual representation. We have twins. And you create a digital twin when you put them into contact. When you have a constant update between a real one and the virtual representation. So you have data flowing constantly, also back and forth. So if in reality something is happening, the virtual is updated. If the virtual is predicting something, this information is presented also to the physical process. In the best case, it's a long time attendance, meaning you don't just create one digital copy. That would be more like simulation and never use it again, only for one time. But you have a constant flow. You have a life cycle of this system. And what is important about a digital twin? It should have an ultra realistic representation of various aspects. Not all the aspects necessarily, but for your use case, for your digital twin, you need to really realistically represent certain aspects. Those that are important. And also, yeah, I put this here on the side. Industry 4.0 is one of the buzzwords you will hear about digital twin as well. I made a very quick, simple example. What could be a digital twin? Maybe this one is not the most useful, but I'm a coffee enthusiast. For me, this would be a great digital twin. The coffee machine example. So we have a real coffee machine. It's in the kitchen. Let's say we have a big office. We have many people. They're all drinking coffee. So what would be your digital twin? What would it look like? Well, you have, of course, sensors because you want to monitor. You need your data feedback loop, sensors of the machine. let's say the water temperature, of course, you like your coffee hot. Depending on how it's connected, you need the water level. So you have some constant supply, coffee bean reservoir. Who doesn't hate it when the coffee's out when you want one? Wouldn't be too bad if you have an operation mode of the machine. So it's running currently, or I mean, this one is a very fancy one, but you know, it takes a lot of time to do the coffee. Let's say you walk down the hall and you're there and it's already a queue in front of your machine. If you have the operation mode visible, then maybe you could avoid this. So a digital twin of a coffee machine could, for example, show this. Also, you could do a cycle counter. I don't know, the water here is quite chalky. After several runs, you need to dechalk the coffee machine. So why not? You could do, of course, a connectivity. I mean, the digital twin, it's great if you can connect to the data by cloud, by internet, etc. Maybe you could order your coffee. I mean, this one will not work so well, but more automatization, Industry 4.0 we are talking. So a digital twin of your coffee machine, you could probably send a mail and say, I want 2 espresso, and the machine would read the mail, get the order, and produce your espresso, and you just pick it up. It would be great. So that's something a digital twins could do for you. And of course, the level of detail is relevant. This is I mean, not a real life example. You could do that. That's not maybe the most useful digital twin, just a good example. And the level of detail you're using is relevant on how good or how useful the digital twin will be for you, but also on how much effort you need for the digital twin. I mean, you get the temperature. That's a pretty off-the-shelf sensor. Cycle counter would be also quite well. Operation mode, you need to already define. You need to do some semantics and programming. Could be more difficult, higher level of detail, but could be worthwhile. So really depends on how you like your digital twin. A quick overview, where is it used? When is it used? So digital twins can be used all across the whole value chain. Of course, since digital, we can start. The digital twin can be born before the real one, for example. So in the beginning of the design and engineering phase, you start with the digital version, you do some simulation, emulation, before you go into the real project, before you do the haptical, the physical thing. So that's one possibility. Then, of course, in manufacturing, you can use it for the production control, for planning future production. Since your twin is alive, it has a life cycle. You can go into the future with your digital version to check on the physical one. Here marked in red today is, of course, that's why our special topic today, the training and education. But you can also in operation and service of machinery, of factories, etc. One of the most prominent cases for digital twins is predictive maintenance. Since you have a experience, you monitor your data and collect all the information, you can predict, okay, if I have 100 cycles, I need to dechalk my coffee machine. If I run 1000 samples, I need to replace some part of my machinery or grease it or something like this. That's also possible. Maybe one point, I didn't even put a subgroup here, but recycle. Currently, circular economy is a growing topic, and it can be really a great benefit when you have a digital twin, not of just your process or your production process, but also of your product, your individual product. It's easier for traceability. You have your digital link, so to say, to the real world object. And in later circular economy, once the object is, well, not going to be used anymore in the classic way, but going to be recycled or going to waste, which would be a shame, but then you have your digital twin and you can check up, okay, what materials is it, what production has it gone through, etc., etc. So recycling, circular economy is also one of the coming use cases for digital twins. Then just very briefly, since this will be also today covered a lot, I'm not the expert here, I'll just quickly go into the acronyms. Virtual reality, so that's one of the ways, since the digital twin is just data flowing around. Humans don't work so well with throwing around data, but with virtual reality, we can work quite well. One of the examples is these special glasses, virtual reality glasses, where you dive deep into a fully virtual environment. What you see is all rendered, is all digital world, virtual world. That's virtual reality. Augmented reality, on the other hand, is you see the reality and you have small add-ons, augmentations. Classic example is the mobile app Pokemon Go, if someone heard it, or some other mobile apps where you use your mobile phone camera, it records the real world, and you have small augmentations, small overlays of digital objects. So that's augmented reality. So it's a mixture, and the real mixture then is the mixed reality, where you have a virtual environment which you can interact in digital ways and the real world, and they are somehow connected. So for example, I pass by my coffee machine, I have my mixed reality glass on, and I see the bean level is at 50%. I need to go, or 10%, maybe I need to buy some new ones. So there you have the interaction, and then the digital interaction would be, for example, I can online order my coffee beans. That would be, I have a real world object, I have a virtual information I get, and I can interact also with the virtual world. Okay, just a few more words on also why we're doing that. And if you're interested in digital twins, where you can get more information, there's the Regio Rhein project, Digital Twin Academy. Today's event is also part of that. Just briefly, that's on the right is the EMR region, if you were wondering. The project is funded by the European Regional Development Fund and the local governments. Here are some partners. We are part of that. You see our NMWP. Greetings to all the other partners who joined us today. Thank you very much. Quick one, why are we doing it? Okay, I explained a bit about digital twins. I guess we have a, as I said, really skilled audience. But nevertheless, digital twins, depending on the level of complexity, it's innovative, but complex. So there's still a gap in training and education needed. So that's why we're trying to build up this academy. We're creating learning modules. Once again, we're creating a community. We're here together, we talk about it, we'll get some information. We develop some training materials, and together with interested partners, we'd like to do some use cases to show what can digital twins do for you, for your company, for your process, etc. A quick information about this one, the first learning modules, they're all free of charge and online available, will be released in September based on our project. We have a lot of running already test cases of digital twins with industrial partners. If you're interested, just approach us. Happy to run a test case with you too. With that, I thank you all for your attention. Don't log out yet. Further questions you can write in the chat. You can contact in the discussion round, or also afterwards. Mail is available. You just got a mail already from me for the link again. So just feel free to reach out. And with this, these are the next speakers. I would like to hand over to Dario.
Yeah, thank you. I will start sharing my screen. Give me a second. So everybody can see now my screen, right? Perfect. Yes. So I'm here to talk about qualification of young managers by means of digital twin. I will talk a lot about virtual and augmented reality. So thank you, Matthias, for introducing the technology a little bit. So I don't have to talk a lot about the specific words and so on. But first of all, I would like to present to you where I'm from, my organization. I'm from, as you can see on the top left, Mittelstand-Digital Zentrum Rheinland, which is part of the organization of Mittelstand-Digital. It's a founded project from the Bundesministerium für Wirtschaft und Energie, so from the government. And this organization has 26 centers of digitalization all around Germany. Also part of that is the Foundation IT Sicherheit in der Wirtschaft, so for cybersecurity, where small and medium-sized businesses or enterprises can get help towards digitalization and also cybersecurity. And also part of that is the yeah, the founding of Digital Jetzt, where small and medium-sized enterprises can get money to invest in new digital technologies, for example. But yeah, that's it. What do we offer in our in our center? We have a lot of yeah, specific formats. They are categorized in the 5 categories of informing, qualifying, implementing, transferring, and networking. So we also do networking. That's why I'm also here. I'm very happy to that I can join this group. And yeah, there we have special formats. For example, right now I'm doing an introduction presentation in yeah, qualification via digital twin. But we also do like potential analysis and yeah, virtual conferences for networking and so on and so on. But another yeah, the last one thing I want to say about our organization is that's our guiding sentence. We support SMEs in the Rhineland to make their companies ready for the future by themselves using digitalization methods and technologies. So yeah, if that's interesting for you, yeah, hit me up, give me a call or connect with me on LinkedIn or something like that, and we can talk about stuff like that after this event. But here, I'm here at this presentation right now at this event to talk to you about yeah, qualification via virtual and augmented reality via virtual twins. So why do we learn in virtual reality? Virtual reality, as we already heard from Matthias, is also a big part of digital twins. You have a digital environment where you can interact with the environment. Most of all the important and specific parts of this environment are simulated, so it feels like a real environment. And yeah, learning in this environment has a special effect. So we can see here we have passive learning, and after 2 weeks of learning, we remember 10% of what we read, 20% of what we hear, 30% of what we see, 50% of what we see and hear. And then that's the interesting part, the active part, what 70% of what we say and 90% of what we say and do. And that's the special thing about virtual environments. We have the learning by doing effect. So when we are in a virtual environment, I have some use cases we have in our center for you later on. But there you can see you interact with the environment, you do things, and you have a specific goal which you want to reach in this environment. And because you do the things, you can better remember these things, and the learning process is more effective. And we also try to combine this with playful elements, so to increase the motivation of the participants, which is also a big part. So the whole gamification aspect of the learning environment, so that you really have the motivation, the goal to reach a specific score or something like that, which triggers the yeah, the motivation of really learning what you are doing or why you are in this virtual reality. And another big advantage is that you have a lot of possibilities of designing your environment and your yeah, your virtual reality game or learning game. So the possibilities are nearly endless. Of course, when it's more advanced and bigger level and a bigger environment or more complex environment, you need more time, and so also it's more you need more it's more costly. So yeah, that's also the part that goes with that. But yeah, as it's as you can imagine, like you can nearly build anything in the virtual environment that you have in a real industry or production factory or something like that. So training and education. Here are the positive aspects. You have fast and efficient learning. You have higher participation and individual support in this environment. For example, when there is a teacher who just talks to you and says to you what's important when you are in the environment and participate, you can make it more individual and more efficient. The intention is higher because you really have to do things. We can collect measurable data and learning progress. So automatically, when you are in a virtual environment and doing a learning game, you can measure like when does the participant do which step, how fast is he, which many mistakes does he make, and so on and so on. And then later on, you can evaluate the process. You can evaluate your game, your virtual environment. You can evaluate the learning steps that you implemented. So you can really see, do the participants learn the parts that you want them to learn? And it's a more automated process. You have a safe practice and dangerous situations. So as you can see, we have a lot of, I will present you one game where we have the safe way you do the safety protocols for welding. And if you do this in real life, of course, there is the danger of harming yourself or others, which isn't in the virtual environment. And because of that, you have cost savings. You can't destroy any parts that are very costly or something like that, because it's all in virtual reality. If you can say maybe the hardware, so the glasses or something like that could be damaged, but in most cases, this isn't the case. And which is you can do all you can. It's more transferable, more scalable. Like for example, when you have constructed one environment, you just need more virtual reality glasses, and more participants can do the same training. If you want to do this on a real machine, if you want to have more participants doing the same education process at the same time, you would need more machines. So there you have a very big cost saving aspect. And here we have some examples from the industry, mainly from car producers, for like example BMW, Volkswagen, and Daimler, where all virtual and augmented reality is used for education and training. And now I will just present you some use cases we have, so we can have a deeper insight in what this really looks like and how you can use this technology for education and training and stuff like that. This is, as I said, the safety training for welding. Here we have, first of all, a tutorial room, so you can get used to the controllers and stuff like that, how you use the things. As you can see, you can beam yourself with this green cycle on the floor to different locations, and you have a 360-degree freedom on your position. As you can see, when you turn around with the glasses, you turn around and around in the room. And here the goal is to get all the relevant safety clauses to really do the welding process. And this is the main part of this first room. So you have different shoes, different gloves and stuff like that. And they all have different safety levels. As you can see further on, you can get the information of the closing parts when you are nearby them. As you can see, you have information. You click on the information, and then it says, okay, these are boots made out of leather, safety class 3 and stuff like that. And then because you have to know what safety classes you need, you really have to look for the right parts, and you can then put them on. And if you've done everything right, because with the look on the time, I will skip a little bit forward. Yes, you can see you can also connect it to a TV screen so other people can participate. As you can see, if you have all the right parts on, the room, the door to the next room is opening, and with the welding room, and there you have the welding process, which you have to do. And therefore you also have to do different variety of things to have a safety welding process. As you can see, you have these boxes which have to be taken out, and you have of course the mask, the welding mask, so to protect your eyes, and you have to check the welding machine and stuff like that. And if you do all this stuff, you will have a successful welding process in the end. Let's see, I will skip a little bit more forward. As you can see, that you should take out the boxes, which is made out of paper, so that these boxes would be easily would start burning. So that's why you have to take them out. And at the end, now you can see it's darker because you have the mask on, and then you can do the welding process successfully. And after that, you can get a congratulations screen and a score. And there, as I said, the motivation in gamification is high because then you can get a higher score if you do the more of the things right and stuff like that. So let's go on to the next example. This is yeah, more about the young manager education. We have a process here where we have an augmented reality game and a virtual reality game or a desktop game. First of all, it's also guided by coaching sessions. And in the augmented reality game, you have to we also try to yeah, educate in communication. So we have a group of 8 to 10 players which have to communicate and build a production facility, a production plan to manufacture little robots. This is a kind of yeah, we did want to make it a little bit funny. So you have to place robots which produce robots, and all these robots have different production steps they can do. And the aim is to quick and cost efficient build this production plant and build together all the different robots which do different production steps. Very cost efficient because, like, for example, some robots can do all the production steps, but they're very slow and very costly. And then you have some robots which can do just one production step, but are very fast and don't cost as much. And if you put together the right assembly of robots, you have a fast and efficient and for especially a cost-efficient production hall. And here we have as well a video which shows how this is made. Of course, we have a lot of introductions. Unfortunately, it's in German, but yeah, as you can see there, you have your plant, and then you have your robots, and you can choose these robots and get some insights in the robots and place them to make a production for like tiny robots in this example. As you can see, you just pull them, place them, and then these production starts. We also have AGVs, vehicles that will transport manually or automatically and autonomously the different production parts to the different steps. And yeah, in the first level, you just need one robot to do all the production, but yeah, in the later stage of the game, you have like 3 or 5 different robots producing all the stuff, and you can you can build your own production hall. This is the first part of the game. The second part of the game, when you build your production facility, then you go inside of this production facility and have to be really on the shop floor and have to do troubleshooting or read error codes because there are some maintenance issues in the production. And there as well, we have group participants, and you have to talk to each other and divide the tasks to different participants and to get the production running on the floor. And as I show you a video, I will talk a little bit about why this is an important part. We do this in our university to teach the students what is important, all the soft skills you don't get to know when you have like the classic study courses like mathematics, mechanical statics and stuff like that. Because when you're finished with the university and you have your master's degree or something like that in engineering, you most of the time you are in a leader position in a company, and then you have to manage different excuse me, you have to manage different employees and look after the production if the production is running, if you're in a production field, and you need a lot of communication skills and management skills. And we try to teach these skills to the students via games like that. And this is really a big part of all these games, is that because you do these things and you really can communicate with all the other participants, you really learn by doing. And that's the specialization of these learning games in virtual reality. And then I will come to the last example really quickly. What we are doing here is we have augmented reality combined with collaborative robotics. And what we are doing here is with the augmented reality glasses, you get support in where the robot will move next, and you get a better understanding of what the cobot is doing, or the robot is doing, to make the interaction and the communication more easy. And yeah, as you can see here, these are visualizations that are presented in the augmented glasses. And yeah, this supports, give you support in the assembly process with the robot. Yeah, thank you very much for your attention. I'm finished with my with my little talk. I guess we do questions later, right?
We have a short minute for 1 or 2 questions. I have one from the chat, which I would read to you.
Yeah.
Mr. Solmas asked, which device do you use for the AR experience? I think it was about the shop floor level.
The shop floor level. Yeah, in shop there we do mobile devices like smartphones, or in most of the cases tablets, because then you have a bigger screen. That's more easy. That's the thing we are doing right now. And as you can see on the, but we also have some experience with the glasses. For these are the HoloLens glasses for Microsoft. We are using with the collaborative robot.
Okay, thank you. Further questions? Otherwise, there is the interactive discussion part where everything else can be asked and explained. Okay, then thanks again.
Yeah, thank you very much.
Then we have oculavis. Mr.
Yes.
Martin.
Can you hear me well? Just
Yes.
to check shortly. Perfect. All right. You need to enable me to screen sharing, or
Should be possible. Or
it says host disabled participants screen sharing.
oh, I'm sorry. Okay.
Now it should work. Yes. So let me see. You should see very soon. Oh, I have one issue. Please give me 1 second. Even though I already enabled for Zoom correctly the screen sharing, it wants to have the permissions again. I'm sorry for the short interruption, but maybe sometimes I need to shortly reopen Zoom on my macOS to allow it. Give me 1 second.
Okay, no worries. Goni is. That is, of course, I mean, one of the things also digital twins have problems with. The running system depends on which one you're using, which sensor, which communication protocol are you using. So digital twins are an IT field, of course, to some extent. So, he's back.
Yeah, once more the permissions, and then it should probably work.
Yes.
Thanks for the in-between communication taking here. I think I just heard that. So let's see.
Now we see a screen.
Perfect. All right. Then, yeah, welcome. Today it's not Martin Plutz, who's one of the founders of oculavis. It's me. My name is Jakob Kämpfer, and I'm working in the research and product management department. And today I will take over and give you some insights from oculavis, and with the title of the presentation, Augmented Reality as Visualization and Interaction Layer of a Digital Twin. And yeah, a short overview. So who is oculavis? We are a software developer, and our goal is to transform industrial processes. And we do this since 2016. To the product itself, I will come on the next slide, but maybe some general information. In this day, we have about 200 customers and internal 64 employees. I started about 2 years ago and was employee number, 1.5 years ago, was employee number 55. And yeah, since then, we're participating also in a lot of research projects facing these topics, and also in a lot of awards regarding startup companies for using and applying AR technology. And also in terms of IT security, we just had it last week, the refreshment of our ISO certification. So we are ISO certificated with 27001 certification. So what do we do? Let's have a look on this picture. And the key motivation, and also in general, we have multiple modules. And the general thing is about troubleshoot, or it started with troubleshooting processes. So people are having calls with hotlines, writing a lot of emails, sending them around to actually get some help to solve an issue that not every time is very complex for a person that is trained or educated to solve such issues on a machine. And therefore, this is the key motivation on how this all started. And to transform these processes, we want to redefine this interaction of how human and machinery get in touch with this equipment. So let's take this picture and let me explain a bit and give an overview of what software we develop. And therefore, if it lets me, I would just use the laser pointer. Give me a second, it's not allowing me to use it, but it's fine. Let's start from the bottom one. So imagine you're on a shop floor and standing in front of a machine. And it can be, yeah, as we are here today for training and education. So general training education, there's no error on the machine, but of course it can be also some errors that are displayed on the machine interface, and you basically have no idea how to do and how to solve it. So let's have a look at the asset relation. You can also see it navigates to a QR code, which is placed on the machine. We offer a product asset relation module where you can store all basic information like a machine manual, which can be about 300 pages long, that when you receive it and when you buy a machine. In our software, you have the possibility to make a tree structure and to reference different pages and of these documents to your machine, so that when you actually scan this QR code, you have access to all this digital information, also very structured. So you don't have to just go page by page to find different parts. If you say, I want to have a more detailed information about the milling head, for example, you place in the product tree a milling head and you get exactly videos, PDFs, reference PDFs to get to know the machine. And if this, let's say, and this is what I just explained, is the relation to the first module over there, which is the AR editor and viewer. So you not only can have a product tree visualizing it, you can also have an augmented reality overlay over the real machine, or also a 3D model visualization. So you don't have to be directly in front of the machine to access all of this training and education material. If the classic way of PDF printed ways or something is not working, or there's just one single video is also not enough, we give the power to the shop floor workers to use digital workflows, which are step-by-step instructions. So you can create, and then in the end, the user can use these workflows to, for example, have a completely process described on how to exchange the milling head from the one tool to the other. And yeah, this is by empowering also and training then users without external help. And if all of these three steps, by trying to give the information needed to the person, does not work, and maybe because this kind of error or this kind of training did never happen like this before, we have the visual assistance module, which you can take as a mix of this Zoom call we are just right now in. So video communication, audio communication, enhanced by annotation, augmented reality annotation modules, and also by the possibility to document, for example, an initial training or more advanced trainings in your system. The support for this part goes over, one solution for all devices. So we have a web browser application and native Mac OS applications. We also have native applications for Android and iOS. For tablets, it's also in some ways tablet screen designed optimized. We have mobile native applications for iOS and Android, and also supporting smart glasses, mostly the RearWear HMT1, which officially is an assisted reality. So it's a HMT1, it's a head-mounted tablet, so to say, with the benefit of working hands-free. and also currently in development, we're experimenting with the HoloLens. So for now, also with the topic in where we are today, I want to focus on the workflows and the IR editor module, because there we address the current need and also for today's session. So the idea is to empower the people, and in the end, I already said it, you have the possibility to include videos. So let's say you have small videos of maybe more complex movements on how to detach the spindle, specific movements that are not very easily to explain by just a single PDF. And you can also do verifications of the same QR code we just showed at the first slide. So, and in the end, this is, what you see is what you get, editor for easy auto-writing editing, this workflows. But if you want to see more to that, you can, of course, also contact me. Let's go here. Here also, you can see on how in the web application you actually create and edit these workflows. And therefore, I want to directly jump to the next part. So this is the augmented reality viewer. Let's have a look on the right side. On the right side, you see an exactly tablet screenshot of how the application looks like. You also see the machine in the background, and you also see then the augmented reality overlay of in that part also of the part of the spindle. And on the left side, you see this part in the product tree is actually called tube. And when you have a look on the upper right corner of the screenshot, you also see the tube with some metadata. So you have, for example, some reference numbers, you have which material it's made of, the serial number, and you can also see below that there are a couple of attached videos, PDFs, and further documents, and also 3 workflows. So in that way, whether I think there are 2 different cases, you're standing in front of the machine, you know to which part you want to access more information, and you just directly click inside the video so that you know in the end it's the tube what this part is called, or you are the other way around and you know on which part you want to have more data, and you don't know where exactly in the machine this part is. So you, on the left side, you have the product tree, you click on it, and you can access all information that is attached in that way. So, and this is what you currently see is the X-ray mode as augmented reality overlay, but all of this also works just as a 3D model representation as you know it from, when opening a CID file, for example. And in that way, you don't have to be physically in front of the machine to have this enhanced digital twin data. You can also access this from everywhere with your internet connection. So in the end, there's a marker placed on the machine, which allows the 3D tracking. I already covered the access to the technical documentation and semi-transparent views as also 3D model overviews. How does it, of course, you need to set up all these things. So you need the CID data in the former and in specific formats. You need to place the marker on where it is so that in the end also we can calculate it in the background. And you need to enhance this product tree by your technical documentation, which you in best case already have. So I think, this is already, we're in minute 9. Okay, so I have a bit more time. So this is the module overview and also on how we bring added values and benefits in terms of digital twins into our software. What is really nice, we really can bring and make some processes which are done normally by trainings coming somewhere 100% digitally, so 100% remote processes, and increase machine availability by having less downtimes. And of course, by letting the knowledge travel and not the technician itself, you can reduce and travel costs, and of course also CO2 emissions. And in general, also by just creating new business models that haven't been there before. Some of our customers, if you're interested on who of our customers already use it in a productive way, you can have a look here. Also, we have some customer success stories who explain a bit on how they actually make it and make use of it. And as the last part, I just want to bring also in another point, which is, Oculavis is also in the research area where I am currently leading from Oculavis side the DReal project, which is a digital remote assistance for laser machining processes. And with us there, we have the Fraunhofer IRT, which is for Institute for Laser Technologies, and also producer for welding robots, Klaus Hema, who does like observation cameras, scans sonic, also like the laser units in front of. And they're also currently, the goal is to get a lot of sensor data from all the different parts of this machine, and also from the external equipment that we have here, and to in the end visualize, and this is our part, visualize all this sensor data inside the video hall, or also inside the IR viewer. So enhancing the, let's say, static data by live data visualization, so that you also can access this from abroad. And also here's one more example from another project, 5G Sense Pro, where we have a heat map from a milling process and have this as an overlay over the real parts to analyze this in more particular. So I think I'm finished a bit earlier. But
you're perfect in time.
I would use this time to, maybe there's some questions. I also have some backup slides, so feel free to just shout out some questions.
Yeah, please the audience, just unmute yourself and shoot. Otherwise, I would have a first question. As I worked in my studies with a lot of different machinery and terrible manuals, do you then is it a trend that manufacturers of machines create, let's say, better manuals that you can implement in your software, or do you really have to do the task and prepare manuals in a handy way?
We in the end do not create the manual. So you have this one thing. So in the end, you have this this product tree that you have like a service product tree. It's not exactly the same as from the CAD model, because they are very complex. You're not interested in single screws, for example. But what you do is you take your 300 pages manual and upload it into our software platform. And then in the end, you can create references of specific pages to access this then. I also have it open. I opened it at least here. So maybe this gives a way better understanding. I hope you can see that, yes. For example. So here we have, this is the full manual that exists that you upload with 73 pages. And then we create this product tree with the different parts of this scansonic laser unit. And in the end, if I click here, for example, it's not a new PDF. It's the same PDF with the reference to page number 52. So when you are on this augmented reality overlay and click on it, you directly get directed to this specific page. So you don't have to create so much new. It's just way better structured. And yeah, I think this is here the idea, and hope it also answers your question a bit. So yes, any more questions or addition to and more deeper questions to that, maybe also from your side?
Yeah, well, thank you very much. I got this one. Yeah, makes sense to structure them and make them easier accessible. If no questions come now, don't worry. There's more time we have the discussion part. So, Mr. Kissmann, if you're ready, stage is yours.
Yes. Hello, and thank you for inviting me to this event. I'm Dominik Kissmann. I'm co-founder of lemontree, and I'm very excited to speak to you today and to talk about our startup and some of our past, as well as the current projects we are working on right now. First of all, I want to give you a quick introduction about lemontree and who we are. We are a young startup founded 1.5 years ago in Münster, Germany. Our core team consists of 3 founders from the architecture and software development area. And our vision is to create a future where all the knowledge of a company can be stored and transferred easily throughout the employees. And this is why we create very immersive applications with virtual reality and web 3D technology. So to get a better understanding how we got here and where we want to go, I will show you some of our first projects. So the first one on the left is NIHAP 1, and it is part of the exhibition Überlebenskünstler Mensch of the LWL Museum of Natural History. And NIHAP 1 simulates a virtual journey to a future Mars station. The visitor is experiencing a very immersive way, in a very immersive way, how an astronaut will survive on the Mars in the future. And you can explore the station freely and even interact with your environment. So a part of the 3D environment was provided by the museum, and we were working closely with the museum to create a very realistic experience. And even in a very cinematic way, as you see here. And the second project was in the industry area, and it was together with the Fraunhofer FFB in Münster, where a battery cell production with its material flows, as well as the whole future factory, was simulated in a multi-user application. So this application was presented last year in a virtual conference, where we see here Minister Pinkwart and also Pfeiffer Pönsken experiencing these future facilities. And the project was a very great success, and both ministers enjoyed this time travel to the future Münster battery productions. Yeah, those are great examples, but we know that VR is only the tip of the iceberg, and we are not focusing only on virtual reality technology, but rather decide which one is the best for achieving the project goals. So during our last few projects, we noticed some recurring problems our clients had to focus. And to illustrate these problems better, we will have a look at a complex machine. This is a forging press, which is operated by an experienced mechanic. And to train new employees how to build, operate, and manage this machine, those employees are regularly flown around the world, which is very efficient, like we heard before. And even during this training process, often language barriers and different learning speeds result in a loss of information. So this can even result in expensive machine damages or even very bad injuries we want to prevent. And that's why we want you to give also a glimpse of a better future we imagine. In this scenario, we also use our virtual trainings platform. We call it Secure, where the mechanics are trained in a combination between a 3D web app and as well with virtual reality. So it's very funny because it's kind of similar. So there are similarities to oculavis before we have seen. So we have a fully web app where you have a 3D model and a representation of the machines you will work on later. And with one click, you can get additional information on the machine, like a handbook and so on. You can assign those informations as well on the machine. So we imagine that you can go there through a online learning path where you get a general idea of the machine. And in the later process, when you finish this, you go into a virtual reality. And now we see in a second through the view of one of our colleagues, Willy, and he's experiencing a virtual environment where you can find a digital representation of the machine he will be working later. And he will be guided step by step in his own language and also in his own speed through the steps, and learns the right moves that are required for the production process. Of course, this is simplified, but you get an idea of the possibilities this offers. And you can even simulate how to behave in different scenarios and what to pay attention to in many different environments. Yeah, so to sum this up, you can start your training anytime and even before the actual production is ready. And the employees can start with self-learning in a safe environment from everywhere with a mobile VR glass, for example. So we have seen a lot of numbers already today, and we see a lot of different studies for different industries, and all have the same conclusion that there are a lot of advantages for virtual learning, and is also very efficient for a large number of people. So, of course, we're still looking for next pilot projects to continue evolving our platform. So feel free to contact us to talk about possible collaborations. And I'm already happy to answer questions.
Okay, thank you very much for your presentation. There were some good examples of the digital version is the twin is born before the real one. But that's a great way. You have your, in that way, cheaper, easier first step, and then you can later realize the real one.
Yes.
I would have a question.
Yes.
Yeah, thanks so for thank you very much for the presentation, for the insights. I was curious about the models that you're using. The ones were really simplified, the others were more detailed. And I would be actually curious if, how you handle this with project partners or customers or in general. Because usually, I mean, sometimes they have slightly simplified files from our experience, but very often they are just, as step data files from the original CAD model, which are huge, have a lot of detail. And I know that from experience, then when you want to do this simplified files, you actually have to reconstruct, reverse engineer that in a more simplified way. So do you dealing there with similar issues, or is this, I don't know if you can tell anything to that. It would be interesting for me, and maybe also for others.
Yeah, for sure. We experienced the same. So there are three kinds of clients we had. The first one, they already have models, and they even had simplified models we could use for the experience. So we only imported those models and just programmed the learning path. And another customer would be one who had some models, and there are also some who have no machine files, just 2D 2D sheet of the machines. In this situation, we made a simplified version of our own. So we used a 3D scan for a rough 3D model, and then we modeled after this 3D scan a simplified version of the machine.
So you offered this as a service to
yes, we offer this as well. But I think the trend in the future will be that more companies will have already their own files. But we were lucky because we were working with a machine producer himself, so he had all those files he needed. Yes.
Yeah, because we were also trying out some automated versions of reducing complexity and file size, but I experienced that it's a hard topic, but yeah, I also saw others raising their hands. Sorry for just rushing in, so I will give the floor to the others now. Thank you very much.
Yeah, thank you for the question. Think
yeah.
Yes.
We can't hear you yet. Where's your microphone going? I used the time quickly and read a question from the chat, or do you?
Sure, go ahead.
We have a question here for the multiplayer applications. Some companies do prefer offline devices due to security issues. Is there any AR or VR specific cybersecurity measures?
Yes, so we worked just in a LAN, a local area network. So it was not really online. It was in the network of the company itself. So there were no outside connections for this. So it would be possible to do this online as well. But for those said reasons, we did this just offline.
Then, Denise.
Yeah, can you hear me now?
Yes.
Yes. Okay. maybe my question is addressed to all the speakers so far, and while not being very familiar with all the implementations of the virtual reality, I was wondering if there is, so to say, a link between the learning success and the way you structure the model in the virtual reality. So there is basically a limit which you can't pass, making the model as realistic as possible, or leaving it as simple as possible.
Mm-hmm. I might start with one answer. So we thought about this a lot, and we had one project where we had different requirements for the outcome or for the experience of the user. Because if you just want to give a broad overview of all those machines, for example, of the facility, then a simplified version is totally fine and enough. But if you're working like in real time, like oculavis on the machine right now, then I think you need a very detailed version, to avoid mistakes and misguiding by the app.
Yeah, same. I think you already covered all about also. No, you're good. Yeah, I mean, I tried to explain also in the presentation when it's really about localizing parts. It highly depends also on the part, but let's say the details of, let's say, the specific screw or that you don't need. It's more the localizing part. If you need to understand. Or if you watch a model in a 3D viewer and you want to then see it in real life, you need some more details. And that's also why I addressed this question as a challenge. It's sometimes it's high detail, sometimes it's very low detail. And in the end, in the best case, you get one 3D model, and then you somehow, in best case, need to offer a service that you always show the detail needed. But that's, I think, is a challenge in the whole chain.
Yeah. So you can imagine maybe in the future that there will be an AI that can understand the model fast enough to make like a lower version of a lower detailed version of the model. But I think this will take some years to get there.
Maybe there I can make a quick link. So we had a webinar about machine vision and the creation of 3D rendered digital twins of real life objects, where in this case the real one was first, and by application of machine vision and some small markers attached to the object, you get a real scaled virtual representation. So there are people working on that. Of course, there it's scanned by hand or slowly scanned by robot. The AI then assigning and saying, oh yeah, I just recorded a screw or a coffee machine or a contraction band or etc. That's the next step. That would be great. That will come, I'm sure. Yeah. But now we're already in discussion. We have one more talk from WinMOD. I'm happy to have our one more speaker. This is in exchange. You're still called Jürgen Mewes, but you are not Jürgen.
No, I'm not. But Jürgen Mewes is with me. I will hold the presentation today. My name is Timos Ioannou. I'm working at WinMOD, and together with Mr. Jürgen Mewes and my colleagues, we're responsible for digital twins especially in the education sector. And I will try right now to share my screen. Give me 1 second. Oops, no, I closed this. So, okay. So, I think you see the presentation.
Yep. Screen is visible.
Very, very nice. Let's start. It's not working. Yeah, right now. So a few things about our company. We are located right next to Berlin. We were founded as Mewes & Partner company. We had a rename this year, and we were founded in 1991 as an engineering office for automation technology. And we developed our simulation system for the branches of factory automation, process automation, and automation engineering. And with this software, we are able to build up digital twins and models for testing automation systems. Let's start and see how right now in real commissioning work. We have two parts. We have on one side the machine plant, the real machine plant, which we want to automate with our automation system. This is connected, and we write our code, connect everything, and hope that it's going to work. Here, our part comes in. We replace the real plant with our WinMOD system and a digital twin. This digital twin, the concept of the digital twin, the term is really, really wide. And we break it down and say that the digital twin for us is a functional digital model of the real system. It's built up of basically 3 models: the configuration model, the device model, and the 3D model. I will come back later to them to explain how they work together and in which one we find what kind of problems and things. So as I said, we replace the real plant with our digital twin and connect this to the automation system we are using also in the plant to test and to do a virtual commissioning on this digital twin before we go to the real plant. As you see, we have a lot of questions which we have to solve and to clear, because our digital twin, our model, is very detailed, very technically detailed, and we try to have the exact functional behavior as in the real plant. So we first start on which technology do you use, production technology, process technology, or others, and especially which automation system you use, Siemens, Beckhoff, and others. And the questions continue and go over to which field bus, which devices, how they work, how is their behavior. To make things a little bit more simple, we have invented IQ. IQ stands for Information, Qualification, and Utilization. And it's a concept to help users understand the system, work with it in an easy and simple way, so they can do it on their own. So especially for the education, we have a system, a concept named IQ Edu, or education, where we have the whole functionality of the WinMOD system brought down to especially the things you need. And we keep it as simple as possible. So we just look at which PLC do you use, a real or a virtual PLC, and which real, of course, and which models do you need. Everything else is prepared from us, very detailed in the same way as in a real proficient industrial plant, but configured so that the user can simply work with it, write direct, and test his code and do a virtual commissioning. We have models and packages like Automation 1, Automation 2, already prepared, which teach the basics of the automation process, like electropneumatics, conveyors, things like that. But we can also do customer-related models on plants that the customer want to use and want to teach to students, or in a company to the workers for, like, for example, a training or something like that. So to go back to the question we had on how we scale those things, we brought into these functional models all the information we need, but we try to keep things that doesn't matter a little bit, but a little bit simple. Make abstract models, not take all the 3Ds just for looks cool, but we take the right sizes, we take the right functionality, the right behavior, so that you can have a one-to-one functional behavior of your digital model exactly as it would be on the real model. And exactly as I said in the industry concept, the same educational model has the same concept. We have the configurational model, which is the connection between the model and the PLC you're using. There you can also find the I/O map and check how your signals interact in real time with your PLC. Then we go over to the device model, which covers the whole behavior of all the devices you have in the real plant. So you can see in a transparent way how from the I/O map you're going over to the device model and how the signals from the PLC in real time interact with the device and what's the device giving out and how it works. Then we go over to the 3D model, which is also made by WinMOD Simline, our 3D design tool. And there you can watch then your material flow, get information about your signals, how they interact, and go back to the device models. I would suggest that I show you one of these models. Give me a few seconds to change. Do you see the model?
Yes.
Yes.
Very, very nice. That's our concept made with WinMOD for IQ Edu. All the projects are built up the same, so the students and the trainees can find, have no problems to find wherever they're looking if they know how to use one model. On the right side, you see the 3D part, the 3D model of our small plant in the real sizes as the real plant. And you can navigate it through this window, look at different stations, zoom in, zoom out, and watch it. You have a source and a sink concept where you can say, where comes my cargo from and where does it go? It goes to the next station that I will see later or in another model. And of course, you have tags and hints with the real devices names and signal names, so you can see them right in the 3D view. We go over to the I/O map, where you have all your signals which are exchanging through with the PLC as PLC outputs and PLC inputs. You can see the addresses and their names, so you can find all your signals over here. We go over to the devices, which covers, as I said, the behavior, the functional behavior, exactly as in the real plant. You can interact, you can see where the signal comes, which signal comes, and what's the output of your device. So you can check if everything's all right, manipulate it, search for errors, and whatever you need. Of course, we have also a recorder where you can write down in real time all the signals that are exchanged and how they interact, also with time to see, okay, is the speed right? Is the signal coming in the right time? What's the problem? Why isn't it working? Things like that. I can make a small demonstration. Normally the model would be connected with a PLC, virtual or real, over maybe Profinet. Right now it's not, just to be faster, and I have to force the signals. It's like manipulating it in a fast and easy way. I will make a cargo over here. You see it in orange. I will say the PLC signal comes and say that conveyor 1 turns on, and you see in real time it changes color into green. That means it's moving. I will push it to the front, push it back, turn it off. I can zoom in. I can turn it on, the first machine, and then say, okay, go down and interact with the cargo. Very nice. I make it off, turn it off, back on. You see the reactions in real time of the lights, exactly as you see it on your I/O map, and the recorder would take note of everything, so you can see if your code works exactly as you want it. I will also have prepared a video for you, which shows how it works in things like testing your code. We have a project with a real robot. You see it over here. It's from a professional plant making bottles and checking bottles. And the robot is over here. You see the virtual model on the back. And it's the situation where we have the digital twin in the virtual world, and we just want to check if the robot works fine, makes everything he wants, just with the robot we have right now. So the digital part is ready before the real part. I will skip a few things. So here you see that it's programmed directly in the software of the robot producer. So you don't have to change, don't have to learn new languages. You're just working with the robot you need. And as you see here, they're working in parallel ways in the virtual world and the real world, exactly how we programmed it in the programming language of the robot. You see again, the devices and things like that. It's of course a way a little bit too complicated because it's an industry project, but that's why we have our IQ Edo system and concept. So we have, as I said, the automation 1 and automation 2 packages. We start at 1 with very, very easy examples, I/O tests, electropneumatics, simple conveyors, just to take the like new students to automation technology and teach them the things they have to learn. But we also have models according to your goals, where we virtualize existing plants and things like that. And I have to tell, like in our model 2, our models, especially for production technology, are modular and combinable. So one part, like the model you see, I showed you a few moments ago, is made of simpler models. So you can start with the simple ones and start to combine them modularly, and then go over to a bigger plan. So you have faster and easier implementations, and the students can learn like how a user conveyor, go over to the machine, and then work in the combination of all together. For more information, we are, of course, you can visit our website. We have a summary where you can download it also on the website, and we have YouTube videos. Of course, on the website, you can call us if you have more questions. And thank you very much. We are both here for questions right now, but also in the questions and answer session.
Okay, thank you for your presentation. If there are immediate questions, just shoot. Feel free to use chat or unmute yourself and ask. Otherwise, I give you a second. Otherwise, we will now switch to concept board. I will provide the link in the chat, just a second. And I will open breakout rooms any second now. Yeah, you're already divided, so it will suggest you a room to switch in. Concept board, it will open in the browser. It's a small. We got a few questions, a bit of support for the discussion open for you, and then feel free to exchange with the other members of your breakout room. Okay. Yeah. Before you go now, after the discussion, we'll have a very brief wrap up again. So we'll come back to the main meeting. Okay. Then the breakout rooms should be a small pop-up coming now for you. Link is also, yeah, perfect, it works. See you in the breakout room. Hello and welcome back, everybody. I hope you had fruitful discussions on our concept board. I see some markers placed in the first question. I see a few challenges being risen. Oh yeah, there has been written some feedback. Thank you very much for that. Yes, I want to give a very brief wrap up. What did we hear today? I hope you took something home with already. But let me wrap it up quickly. I mean, we had four very nice talks where you saw the broad possibilities of training and becoming educated, getting to know a new workplace in the virtual environment, working on a digital twin, learning on a digital twin. And then later, once you are at the real thing, you know what to do. So that was really great. I would just very briefly go over give me a second, over our board. So I was in room 1. We had wonderful discussion. Okay, we see here digital twins are medium to high effort. We only see little challenges, which is great. The best applications, or the most potential potent applications we came up with were the planning of production processes, education. That's great. Then today was worthwhile, and the product engineering. Okay, let's see. In your group 2, I think you're the more optimistic ones. I see more on the benefit area than on the effort area. That's pretty nice. Okay, the DT concept is still vague. When I read this, please just check out in our webinars or come back to our other DTA events, because there exist very well defined, very good definitions of the DT concept. Yeah, come back to us. You will learn the concept is pretty much ready. IT security, very big topic always. Great, you mentioned that. I think there with the local solutions, the problem can be solved. Autonomous vehicles, that's a great use case. Yes, I think there's only one automotive distributor right now being classified for the first level of autonomous driving. It would be great to see digital twins working on that for the next levels. Architecture and building industry, yes. I think this whole industry sector has with BIM, as a building information management, already a great area where a digital twin concept can really be used well. Yes, thank you for that. with this, if there are any more questions, now's the time, shoot. Otherwise, feel free to contact us per mail. You get a mail soon enough also when we cut this video finish in YouTube, where you can rewatch if you had any questions, want to see a slide again. Thank you all for joining. It was a great pleasure to have you all here. I hope you learned something from the discussions. And with this, in Germany, there's a holiday tomorrow. So I would say have a nice holiday.